Good evening, students. Good evening, all of you. Good evening, all my dear students. Good evening, all of you. Join fast. Good evening, students. Good evening, my dear students. Join fast. Join fast. It was almost 7-1. What happened? I think exams are going on. Okay, let me start with my introduction. Myself, Venkata Krishna. My qualification is MTech Computer Science from IIT Kharagpur. I cracked GATE examination with All India rank 22. I had more than 15 years of teaching experience, particularly in GATE, in training the students across the country in 3 different subjects: design and analysis of algorithms, that is DA, core subject for computer science students; engineering mathematics for all students; discrete maths again for computer science students. Welcome to Unacademy. Unacademy is the best online platform in India for all competitive examinations. Why it is best? In terms of what I am saying this is best, let me give more clarification. So let's talk about the types of subscriptions in case of Unacademy at first, and available features and fee structure. Based on that, we can say it is best. In case of Unacademy, basically you can find 2 types of subscriptions. One is a plus subscription. You can find plus symbol here, plus subscription. Another one is star symbol. This is Unacademy iconic. So in Unacademy Plus, you will be having 4 features. One feature is live class. Very important feature, live classes. Structured schedule will be there. Test series will be there. And this is most important salient feature of Unacademy Plus. Unlimited practice. What does it mean? Every day faculty will pose questions on the name DPP. What it stands for? Daily practicing problems. In addition to the problems solved by a faculty member, whether it is in a special class or YouTube class. So to practice, to get practice from student side, even faculty members, educators, we are posting questions every day. And after a few days, again, we are sharing the detailed solutions of DPP. So it gives a lot of confidence among students to crack any competitive examination. Now let's talk about iconic available features. In case of iconic, again, you will be having 4 features. One feature is a personal coach. One personal coach will be appointed to you. Study planner will be there. You will be having guidelines from experts of subjects. And you have a lot of questions and answers of engineering service examinations, ESE mains questions and answers. Right. Now let us talk about the duration of Unacademy Plus subscriptions. What will be the duration of Unacademy Plus subscription? You can find various month subscriptions, and let us see the cost. In case of Unacademy Plus, generally you have 1 month subscription, 3 months subscription, 6 months, 12 months. Recently, 18 months subscription has been introduced recently, 1.5 years, and even you have 24 months. So as a faculty, we always suggest students to take subscription at least for 12 months. At least for 12 months. Now let's talk about 12 month subscription, 18 month subscription, and 24 month subscription. In case of 24 month subscription, after using my referral code GVK10, the fee structure will be 27,225. If you feel that this is burden to pay at a time, even you have EMI option. It is 2,269 rupees per month. So you pay this amount continuously for 12 months. So you will get subscription for 1 year. In case of 18 month subscription, after using my referral code GVK10, the subscription cost will be 34,650. If you feel that this is burden at a time, if you feel it is burden, you have EMI facility. So in this case, it is a 1925 rupees per month. Now, in case of 24 months, after using my referral code GVK10, it will be 39,600. Here also we have EMI option. So for 24 months, it is 1650 rupees just. Now let's talk about Unacademy Iconic. In case of Unacademy Iconic, you will be having subscriptions for 12 months and 24 months only. Only two types of subscriptions. In case of 12 months subscription, after using my referral code GVK10, the fee structure will be 45,225. 45,225. So this is EMI 3,769. In case of 24 months, after using my referral code GVK10, so you get subscription just for 66,600 rupees. In case of EMI, if you prefer EMI option, it will be just 2,775 rupees per month, 24 months. Okay, right. Right. Good evening, Srinivas Rao. Good evening, Mahesh Babu. Right. Now, in this session, let's discuss about basic definitions and examples which are prerequisite for vector space concept. Okay. In the very recent session, we had to talk about abelian groups. We had to talk about groups. We had to talk about semi-groups. We had to talk about monoids, and we have seen some examples. Even let me continue few examples, because in the last session, in the very recent class, we took examples of matrices where all elements are equal. Even we took an example of power set of a non-empty set S with respect to symmetric difference of sets. So today we discuss two important operations, namely addition modulo M and multiplication modulo M. Based on that, we can go for two groups, and even we have nth roots of unity. Okay, so let's continue examples of abelian groups for few minutes. So after that, I will discuss exact definition of ring, commutative ring, examples of rings, and then I will proceed to definition of a field along with examples. If time permits, mostly today I will go for even definition of vector space also. Even if time does not support today, don't worry. At least I can finish few examples on abelian groups. It takes minimum half an hour. After that, I will go to definition of ring, commutative ring, examples, field. So if you understand these things very clearly, I think vector space will be very, very simple. So let us do not worry about syllabus completion. Let's go at least with moderate speed. Okay. So in this session also we continue at least few examples of abelian groups. Okay. Suppose I am starting with consider the set G equal to set of 1 minus 1 I minus I. Here my set contains only 4 elements, 1 minus 1 I minus I. Here I am taking star because whenever I want to discuss a group, algebraic system is required. That is, one binary operation is required. Here star is dot. So what it means, this is usual multiplication, normal multiplication. Here how many elements are there inside set G? Only 4 elements. So when a set contains finite number of elements, in order to prove that a finite set for a group property, so we don't prove generally. So I need to construct a composition table. So by taking 1 minus 1 I minus I horizontally as well as vertically. So let me construct composition table. You can easily understand in what way I am going to prove closure, associative, identity, inverse and commutative properties. Okay. So here I square is minus 1 as usual. I square is minus 1. It is an imaginary number. Here you can see G is nothing but set of all fourth roots of 1. Set of all fourth roots of 1. Very simple. Take x equal to 1 power 1 by 4, fourth root of 1. Apply power 4 on both sides. X power 4 equal to 1. So this becomes x square whole square minus 1 whole square equal to 0. So this equation becomes x square minus 1 into x square plus 1 equal to 0. So you simplify this, you will get 1 minus 1 I minus I. We got the elements of G. So here elements of G are nothing but set of fourth roots of 1. Set of fourth roots of 1. So here my task is to prove that these elements form an abelian group with respect to usual multiplication. Okay, right. Now I am constructing a composition table. You can easily understand, don't worry. Composition table is very simple. Here my elements are 1 minus 1, I minus I. Take the elements horizontally, take the elements vertically. 1 minus 1, I minus I. So I am going to construct, I am adding rows and columns. Now later on I will try to fill the elements of these things. Now here look at this. This is my operation. This is multiplication. Dot. Now multiply elements from column wide as well as vertical wide. So this element becomes 1. 1 into 1. Multiply this one with 1. 1 dot 1. So multiply 1 with horizontally these elements. 1 into minus 1 minus 1. 1 into I. 1 into minus I minus I. Now next you multiply minus 1 with all elements horizontally. So you multiply minus 1 with 1. You fill here minus 1 into 1 minus 1. Minus 1 into minus 1 plus 1. Minus 1 into I minus I. Minus 1 into minus I plus I. Now multiply I with all elements horizontally. So this is I into 1 I into minus 1 minus I into I square, it is minus 1, I into minus I square. Already I square is minus 1. So this entry is becoming 1. Like this becomes minus I. This is plus I. This is 1. Minus I whole square is same as I square, that is minus 1. Now this is my composition table. I think this point is clear. This is my composition table. Now based on this composition table, how I am going to say that it satisfies closure, associative, identity and inverse properties. Look at this. So this is a top row. Now I am going to discuss closure law at first. What is closure law? Basically, the meaning of closure law is this: A star B belongs to G for all A comma B belong to G. అంటే జీలో మీరు ఏ రెండు ఎలిమెంట్స్ తీసుకున్నా ఆ కరెస్పాండింగ్ ఆపరేషన్ అప్లై చేస్తే వచ్చే రిజల్టెంట్ ఎలిమెంట్ కూడా సేమ్ సెట్ లో ఉండాలి. దట్ షుడ్ బి ట్రూ ఫర్ ఆల్ a comma b belong to G, but G contains 4 elements. So one element can be operated to remaining 4 elements with 4 ways. So like that 16 pairs will come. 16 elements ento chudandi. Look at the pre-composition table. Here this is my composition table. Here all elements of composition table are again elements of same matrix. See, here you got 16 elements. Here you got 16 elements. Just you can look at this one and this one. You can call it as a 4 by 4 matrix. Inside a 4 by 4 matrix, you can find 16 elements. 16 elements ela vastunayi when every element of G is multiplied with every element of G. So 1 is multiplied with all the 4 elements. Minus 1 is multiplied with all the 4 elements. I is multiplied with all the 4 elements. Minus I is multiplied with all the 4 elements. Like that you will get 16 combinations and 16 results vastunayi. So 16 elements can be treated as a 4 by 4 matrix. Here all elements inside the matrix are again elements of same set G. It means that closure law is verified. Got this point? So I am going to write that. Since all elements of a composition table are elements of G, implies G satisfies closure law with respect to dot. Any doubt in this point? Point is clear. Next, associative law. I am going to talk about associative law. See, what are elements of G? Normal elements, 1 minus 1, I minus I. Few numbers are real, few numbers are complex. When you take real or complex numbers, associative property will come always. So I can write directly. So directly I can write A dot B dot C equal to A dot B dot C for all A comma B comma C belong to G. This is very clear. Next, let us talk about identity element. Could you say what is identity element in this example? Answers please. What is identity element? What is identity element of this particular set? See, always remember one thing, when you are managing with multiplication operation, look at whether 1 is available in this or not. Here you can see top row is 1 minus 1, I minus I. Here also this row is matching, first row. Top row and first row are same. Here my elements are 1 minus 1, I minus I. They maintain same series, 1 minus 1, I minus I. So therefore top row matches with a row which is headed by 1. It means that 1 is an identity element with respect to multiplication. I think this point is clear. Simple thing, when you are dealing with addition operation, recall that whether 0 is a member of that particular set or not, because when you add every element to 0 you will get back the same element. మీరు ఎప్పుడైనా ఎడిషన్ ఆపరేషన్ ట్రీట్ చేస్తుంటే, వెన్ యూ ఆర్ డీలింగ్ విత్ ఎడిషన్ ఆపరేషన్, 0 అనేది ఆ సెట్ లో ఉందా లేదా వెరిఫై చేసుకోండి. ఎందుకంటే అన్ని ఎలిమెంట్స్ ని 0తో యాడ్ చేస్తేనే సేమ్ ఎలిమెంట్స్ వస్తాయి. ఇన్ దట్ కేస్ 0 విల్ బి కాల్డ్ యాజ్ ఎడిటివ్ ఐడెంటిటీ. అదే మీరు మల్టిప్లికేషన్ గురించి మాట్లాడుతున్నారు అనుకోండి, సో వెన్ యూ మల్టిప్లై ఎవ్రీ ఎలిమెంట్ విత్ 1 యూ విల్ గెట్ బ్యాక్ ద సేమ్ థింగ్. దిస్ ఈస్ అ వెల్ నోన్ ఫ్యాక్ట్, బట్ you make sure that 1 is an element of that. Here my operation is multiplication, so definitely 1 is an identity element. But how to write this? Here the top row, first row elements are 1 minus 1, I minus I. Here 1 minus 1, I minus I. So the top row matches with a row which is headed by 1. Dini heading endandi 1 andi, dini heading 1. So it means that 1 is identity element. Sir 1 direct ga idantha enduku sir direct ga raseyochu kada ante, ఎగ్జామినేషన్ లో వాడు ఏం చేస్తాడంటే ఒకసారి 1 minus 1, I minus I ఇవ్వకుండా వాడు ఏదో సింబల్స్ ఇలా ఇస్తాడు, ఆల్ఫా బీటా గామా డెల్టా ఇస్తాడు. సో టాప్ రోతో డెల్టాతో వచ్చే రోతో రెండు సేమ్ అయ్యాయి అనుకోండి. ఇన్ దట్ కేస్ డెల్టా ఈస్ గోయింగ్ టు బి మై ఐడెంటిటీ ఎలిమెంట్. ఇన్ దట్ కేస్ యూ డోంట్ అండర్స్టాండ్ వాట్ ఈస్ డెల్టా. So because alphabets are given, alpha, beta, gamma, delta. So composition table can be given. In that case, if a row matches with a row headed by a particular symbol, that is going to be identity element. I think point is clear. So in this case, here I am going to write this. Since top row matches with a row headed by 1 implies 1 is an identity element with respect to dot. So I got identity element also. Next I should go for inverse property. Okay, this is identity element, or I can say identity law, or you can say existence of identity. This is existence. Next one is inverse law. So what shall I prove to say that inverse law verified? Inverse exists for every element. So what does it mean? Existence of inverse for every element. This is important. So what is identity element in the previous case? It is 1. So I should prove this one. A star B equal to B star A equal to E. If this happens, I can say that inverse of A exists, and inverse will be denoted by A inverse, that is given by B. సో సెట్ లో మీకు ఎన్ని ఎలిమెంట్స్ ఉన్నాయండి? 4 ఎలిమెంట్స్ ఉన్నాయి. ప్రతి ఎలిమెంట్ కి ఇన్వర్స్ ఎగ్జిస్ట్ అవుతుందని ప్రూవ్ చేయాలి. ఓకే, లుక్ ఎట్ దిస్, వెరీ సింపుల్. 1.1 ఈక్వల్ టు 1. This implies what is 1 inverse? 1 inverse is 1. Next -1 ని ఏ ఎలిమెంట్ తో మల్టిప్లై చేస్తే 1 వస్తుంది, -1. -1 into -1 equal to 1. So implies -1 whole inverse equal to -1. Next I ని ఈ సెట్ లో -i తో మల్టిప్లై చేయండి, మీకు 1 వస్తుంది, ఐడెంటిటీ ఎలిమెంట్. దిస్ ఈస్ ఆల్వేస్ రిజంబ్లింగ్ దిస్ ప్రాపర్టీ. A star B ఈక్వల్ టు E. సో ఏ ప్లేస్ లో I అస్యూమ్ చేసుకోండి. స్టార్ అంటే మల్టిప్లికేషన్. హియర్ B ఈజ్ -i. When you multiply I with -i, then only you are getting identity element, because when you are trying to get inverse property, identity element plays very, very important role. So in that case, what will happen is I inverse is -i. Next -i అనుకోండి. I కి ఇన్వర్స్ -i వస్తే -i కి ఇన్వర్స్ I వస్తుంది. -i ని I తో మల్టిప్లై చేయండి, ఐడెంటిటీ ఎలిమెంట్ వస్తుంది. So therefore here -i whole inverse equal to I. Now you can see this is an element of G. 1 కి ఇన్వర్స్ వచ్చింది, ఆ ఎలిమెంట్ G లో ఉంది. -1 కి ఇన్వర్స్ -1 వస్తుంది, that is an element of G. I inverse is -i, that is again an element of G. -i whole inverse is I, that is again an element of G. So existence of inverse for every element, that is happened in this case. So inverse property is clear. Next, commutative law. రైట్, కాంపిటేటివ్ ఎలా చెప్పొచ్చో చూడండి. ఇవన్నీ నార్మల్ నంబర్స్, టేబుల్ బేసిస్ ఎలా చెప్పొచ్చో చూడండి. సింపుల్ థింగ్ హియర్, సపోజ్ ఇఫ్ యూ కాల్ ఇట్ యాజ్ దిస్ ఈస్ ఎ 4x4 matrix, call it as M. Just you can look at this one. I am circling this you can call it as M. Here you can look at this, M is same as M transpose. It is a symmetric matrix. First row is same as first column, second row is same as second column, third row is same as third column, fourth row is same as fourth column. It means that matrix M is equal to its transpose. అంటే దాని అర్థం ఏంటో తెలుసండి, A dot B equal to B dot A. వెరీ సింపుల్ అండి. ఇక్కడ మీకు 1 ఉంది అనుకోండి, ఈ 1 ఎలా వస్తుంది? దిస్ వన్ ఈస్ -i dot I minus I dot I. ఇంకో రకంగా ఎలా వస్తుంది I dot minus I. So that means that A dot B is same as B dot A. It means that the matrix of composition table is symmetric matrix. Hence, it satisfies commutative property with respect to dot. I think the point is clear. Since M equal to M transpose implies G satisfies closure law, commutative law. G satisfies commutative law with respect to dot. Therefore, my conclusion is G comma dot is an abelian group. G comma dot is an abelian group. Any doubt, students? Any doubt? Mahesh, are you following? Srinivas, are you following? No issues at all, right? Points are clear. So in this case, G comma dot is going to be an abelian group. G comma dot is going to be an abelian group. Now, let us discuss one important definition. That is addition modulo M. The title is itself addition modulo M. Symbolically, we can write like this, plus M. Just you write M below plus. So how to define addition modulo M? Let me define orally at first. Suppose we are dealing with two integers A and B. Integers can be positive, negative, even zeros or allowed. So I am dealing with two integers A and B. M is a fixed positive integer. So apply this operation between A and B. What will be your result? Let us see. Let A comma B belong to Z and M be a positive integer. Then A plus MB. This is nothing but small r. This is read as A addition modulo MB. Then A plus MB equal to R. What is R? Where R is the remainder when A plus B is divided by M. Simply, we can write like this. A plus MB is nothing but A plus B. You apply percentage operator. I think this is clear. So just to take any two integers A and B. M is a fixed positive integer. Apply plus M between them. What will be your result? If you assume that your result is R, then what R indicates? R is nothing but a remainder when A plus B is divided by M. Remainder operator is denoted by percentage M in C programming. Am I right? Mahesh Babu, what is your doubt? Sir, once explained inverse law using table. Why not? Inverse law. Okay. Right. You please look at this. Here one is an identity element. This is an identity element. Identity element plays very important role in getting the inverse. So మీకు ప్రతి ఎలిమెంట్ కి ఇన్వర్స్ ఫైండ్ అవుట్ చేయాలి. ఈవెన్ స్టార్టింగ్ విత్ ఐడెంటిటీ ఎలిమెంట్ ఆల్సో. సో ఫస్ట్ రోలో చూడండి 1 ఇక్కడ కనిపిస్తుందండి. ఫస్ట్ రోలో 1 మీకు ఈ పొజిషన్ లో కనిపిస్తుంది. It means that when 1 is multiplied with 1, you are getting 1. The point is clear. So 1 ని 1 తో మల్టిప్లై చేస్తేనే 1 వస్తుంది. నెక్స్ట్ -1 రోలో రండి. -1 రోలో మీకు 1 ఇక్కడ కనిపిస్తుంది ఈ పొజిషన్ లో. It means that when -1 is multiplied with this -1, you are getting 1. Next, come to ith row because I am searching for inverse of I. So ith row లో మీకు ఐడెంటిటీ ఎలిమెంట్ లాస్ట్ లో వస్తుంది 1. It means that when I is multiplied with minus I, then only you are getting 1. Next minus I రండి. Minus ith row లో 1 ఈ లొకేషన్ లో కనిపిస్తుంది. It means that when minus I is multiplied with I, then only you are getting 1. So the same points I wrote here. The same points I wrote here. 1 dot 1 equal to 1. This is resembling A star B. ఈ ఈక్వేషన్ తో కంపేర్ చేయండి. A star B equal to E. ఇక్కడ A star B అన్నా B star A అన్నా ఈ ఒకటే వస్తుంది. So here I did not consider B star A. Indirectly it is considered. So A value 1 అండి. Star అంటే dot. B value 1. E value 1. So A star B equal to E. అప్పుడు 1 inverse ఏమొస్తుంది? 1 వస్తుంది. Similarly minus 1. When minus 1 is multiplied with minus 1, then only you are getting 1. Next, I ni a number to multiply చేస్తే 1 వస్తుంది. Minus I. Next, minus I ni a number to multiply చేస్తే 1 వస్తుంది. I. So, in this case, just I have used A star B equal to E. What is E? In this case, 1. Star is normal multiplication. 1 ni 1 to multiply చేస్తేనే 1 వస్తుంది. So, 1 inverse is 1. Minus 1 ని minus 1 తో multiply చేస్తేనే 1 వస్తుంది. So minus 1 whole inverse is minus 1. What about I? When I is multiplied with minus I, then only you will get 1. The same thing happens in case of minus I. When minus I is multiplied with I only, you will get back identity element 1. So in that case, I inverse is minus I and minus I whole inverse is I. Is it clear? Very good. Right. Now let us talk about this addition modulo m. Here we are dealing with the two integers a and b. They can be positive, both can be negative, one can be 0, one can be positive. You can take random numbers a and b. Here m is a positive integer. M value matram kachithanga positive integer avali. Now this is the notation. This is read as a addition modulo mb. Here I wrote symbol very clearly, plus m. So that is addition modulo m. So when you apply plus m between a and b, you will get some number. I can call it as r. What r denotes? R is the remainder when a plus b is divided by m. In simple words, I can say like this. Let us take examples. You can understand easily. మీరు examples ఇస్తే చాలా ఈజీగా వస్తుందండి. Suppose I am taking 2 plus 7. 2 plus 4, 7. Addition modulo 4. 2 ni 7 ni add చేయండి. Apply modulus 4. 2 plus 7 is 9. 9 mod 4. 9 ni మీరు 4 తో డివైడ్ చేయండి. రిమైండర్ 1 వస్తుంది. That's it. Example 2. Suppose you take 3 plus 6. This is say for example 15. Addition modulo 6. So this is nothing but 3 plus 15. First 3 ni 15 ni add cheyandi. Apply percentage 6. 3 plus 15 entandi 18. 18 mod 6. 18 ni 6 తో డివైడ్ చేయండి. You will get remainder 0. అంటే మీరు ఏ నెంబర్ అయినా 6 తో డివైడ్ చేస్తే రిమైండర్స్ 0 to 6 minus 1, 0 to 5 వస్తాయి. Understand? So suppose if you divide any number with 6, the possible reminders are 0, 1, 2, 3, 4, 5. Am I right? You divide any number with 4. The possible reminders are 0, 1, 2, 3. You divide any number with m. The possible reminders are 0, 1, 2, and so on, m minus 1. Now with these elements and with this operation, I am going to prove that this is an abelian group. Understand? Right. Now let us take an example. This is general problem. Prove that Z6 0, 1, 2, 3, 4, 5 is an abelian group with respect to plus 6. My operation is plus 6. So notation is very clear. My notation is Z6. What is my addition modulo operation? Plus 6. So when you divide any number with 6, the possible reminders are from 0 to 5. So I elements తీసుకుంటున్నాను. So I want to prove that this is an abelian group with respect to plus 6. How many elements are there? 6 ఎలిమెంట్స్ ఆర్ దేర్. సో మీరు ఎప్పుడైనా సరే ఒక సెట్లో లిమిటెడ్ నెంబర్ ఆఫ్ ఎలిమెంట్స్ తీసుకొని దాన్ని గ్రూప్ కానీ సెమీ గ్రూప్ కానీ మోనైట్ కానీ మీరు వెరిఫై చేయాలంటే అల్టిమేట్ చాయిస్ ఈజ్ కన్స్ట్రక్షన్ ఆఫ్ ఏ కాంపోజిషన్ టేబుల్. అండర్స్టాండ్? రైట్. Now I am going to construct a composition table. So let me construct composition table by taking plus 6. Elements are like this: 0, 1, 2, 3, 4, 5. Take the elements vertically: 0, 1, 2, 3, 4, 5. Now let us fill these elements. So this is 0, 1, 2, 3, 4, 5. Am I right? So 1 తో చూడండి, 1 plus 0, 1. 1 mod 6 ఎంతండి? 1. Next 1 plus 1, 2. So you will get like this: 1, 2, 3, 4, 5, 0. Next 2 తో చూడండి, 2, 3, 4, 5. 2 plus 4 ఎంతండి? 6. 6 mod 6, 0. 2 plus 5 ఎంత? 7. 7 mod 6, 1. సో నంబర్స్ మళ్ళీ రివర్స్ అవుతాయి, రిపీట్ అవుతూ ఉంటాయి. సో హియర్ ఇట్ ఈస్ 3, 4, 5. 3 plus 3, 6. 6 mod 6, 0. Here it is 1. Here it is 2. Next this is 4, 5. 4 plus 2, 6. 6 mod 6 అంటే 0. So again my elements will be continuous: 0, 1, 2, 3. Here it is 5, 0, 1, 2, 3, 4. Now this is my composition table. You can easily understand. Nothing great in this. Now you can easily understand. Any doubt in this on this table? Students, do you have any queries on this? Problem is clear. Okay, so construction of composition table. Now this is a 6 by 6 matrix. Thirty-six elements ఉంటాయి చూడండి. All elements are again elements of Z6 only. So closure property is clear. Associative is clear. Identity will be 0. Inverses అవన్నీ ఎలా వస్తాయో చూద్దాం. Let me write out all the points. So let me discuss closure law at first. Here I can say like this: since all elements of composition table are elements of Z6 implies Z6 satisfies closure law with respect to plus 6. So closure property is clear. Associative you can write directly. You can directly write like this: A plus 6 plus B plus 6 C plus 6 C. This is same as A plus 6 B plus 6 C for all A comma B comma C belong to Z6. So associative property also clear. What is identity element in this case? మీరు ఎడిషన్ చూస్తే మీకు ఆటోమేటిక్గా 0 గుర్తు రావాలి. సో 0 ఈజ్ ఐడెంటిటీ ఎలిమెంట్. No doubt in that case. Next we talk about inverse. This is very important. Inverse law. So inverse law means existence of inverse for every element. Existence of inverse for every element. Now let's talk about inverses. Let's go through previous table, composition table. 0 కి inverse find out చేయాలి. 0th row లో మీకు ఐడెంటిటీ ఎలిమెంట్ ఎక్కడ వస్తుందండి? హియర్ ఇట్ ఈస్. సో 0 కి ఇన్వర్స్ ఎవరు? 0. నెక్స్ట్ ఫస్ట్ రో లో మీకు 0 ఈ లొకేషన్ లో వస్తుంది. It means that when 1 is operated with 5, then only you are getting 0. So 1 inverse is going to be 5. Got it? Next, second row చూడండి. Second row లో మీకు ఐడెంటిటీ ఎలిమెంట్ 0 ఈ పొజిషన్ లో వస్తుంది. It means that when 2 is operated with 4, then only you are getting 0. So it means that inverse of 2 is going to be 4. Next, come to 3. In the third row, you are getting 0 in this position. It means that when 3 is operated with 3, then only you are getting identity element 0. So 3 inverse is 3. Like this, 4 inverse is becoming 2. 5 inverse is becoming 1. I think from the table, now you can easily analyze inverses of every element. Let me write out those points. So here I am going to write like this: 0 plus 6, 0 equal to 0. This implies 0 inverse equal to 0. Next, 1 plus 6, 5 equal to 0. So this implies 1 inverse equal to 5. 2 plus 6, 4 equal to 0. So this implies 2 inverse equal to 4. Next, 3 plus 6, 3 equal to 0. This implies 3 inverse is 3. Next, 4 plus 6, 2 equal to 0. So this implies 4 inverse equal to 2. Next, 5 plus 6, 1 equal to 0. This implies 5 inverse equal to 1. Inverses are possible for every elements which are in the same set. See, I followed this definition. A star B equal to E. ఇక్కడ E అంటే 0 అండి, స్టార్ అంటే +6. So if A star B equal to E, what will be inverse of A? B. According to that definition only, I made all these points. So this one, this line and last line, they are based on this particular line. If A star B equal to E, then A inverse is going to be B. A inverse is going to be B. Point is clear? No issues at all. So inverses are possible. Next, commutative law. You can directly write like this: A plus 6B is same as B plus 6A for all A comma B belong to Z6. A plus B ని 6 తో యాడ్ చేసి 6 తో డివైడ్ చేసినా, B plus A ని 6 తో డివైడ్ చేసినా సేమ్ రిమైండర్స్ వస్తాయి. సో commutative property is clear. So therefore in this case Z6 comma plus 6 is an abelian group. Z6 comma plus 6 is an abelian group. Right. Now I am going to discuss multiplication modulo M. After that I will prove it a group. Maybe it takes some 10 to 15 minutes. After that let me discuss definition of ring, definition of commutative ring, definition of field along with examples. Okay. Next definition, multiplication modulo M. So previously we dealt with addition modulo M. Now it is multiplication modulo M. So definition is more or less same. In place of plus you will get multiplication. Let a comma b belong to z. Here z stands for set of integers and m is a fixed positive integer. So I am writing z plus. Then a cross mb. See the difference. Previously I wrote this notation plus m. Now it is cross m, multiplication modulo m. This is nothing but r, where r is the remainder when a into b is divided by m. That is, a cross mb is nothing but ab percentage m. ab percentage m. Just to multiply those numbers directly, divide with m, you take the possible remainder. Let's take examples. Suppose I have 2 cross 4. Say for example this is 7. Cross 4, multiplication modulo 4. First 2 ni 7 ni multiply cheyandi. 2 into 7 modulus 4. 2 into 7 entandi 14. 14 ni 4 tho divide cheyandi. 4 3 is 12. Remainder is 2. Suppose I have like this. 2 cross 5, 10. So first 2 ni 10 ni multiply cheyandi. 2 into 10. Apply modulus operator. 2 into 5, 10 is 20. 20 ni 5 tho divide cheyandi. The remainder is 0. I think this point is clear. Now I am going to with the multiplication modulo m with a few specific number of elements. I am going to prove that they form an abelian group. So in multiplication modulo 7 తీసుకోబోతున్నానండి. Multiplication modulo 7. I am going to use the same notation. Prove that Z7 equal to. Suppose if I take Z7 comma plus 7, what will be my elements? If I take operation Z7 comma plus 7, addition modulus 7, my elements will be from 0 to 6. With respect to addition modulus 7 తీసుకుంటే identity element నాకు exist అవ్వాలి. So which will act as identity element? Definitely 0. So నేను multiplication modulus 7 కూడా Z7 notation వాడుతున్నాను. So elements have to be changed. Elements ఎలా ఉండబోతున్నాయో చెప్పండి. How elements look like? Elements ఎలా ఉండబోతున్నాయో చెప్పండి. Did you understand my point? Previously I used notation Z6. Then Z6 notation what an earlier. Z6 comma plus 6. So my elements are 0, 1, 2, 3, 4, 5. ఆ ఎలిమెంట్స్ కూడా ఎలా గుర్తుపెట్టుకోవచ్చు సార్? వెరీ సింపుల్. ఎడిషన్ మోడ్యూల్లో 6 కదా, మీరు ఏ నెంబర్ అయినా 6 తో డివైడ్ చేస్తే రిమైండర్స్ 0 to 5 వస్తాయి. 0 లేకపోతే అడిటివ్ ఐడెంటిటీ ఎలిమెంట్ ఎగ్జిస్ట్ కాదండి. సో therefore when the operation is plus 6, take the elements from 0 to 5. My notation will be Z6. Now here I am going to use multiplication modulus 7. Multiplication modulus 7. మీరు ఏ నెంబర్ అయినా 7 తో డివైడ్ చేస్తే రిమైండర్స్ 0 to 6 వస్తాయి. బట్ కెన్ ఐ టేక్ 0? నో యూస్. నో శ్రీనివాస్ రావు. ఇఫ్ ఐ టేక్ 0 to 6, నేను 0 to 6 తీసుకున్నాను అనుకోండి. హియర్ ఇట్ ఈస్. సపోజ్ ఇది తీసుకున్నాను అనుకోండి. ఆపరేషన్ క్రాస్ 7 కదండి. వాట్ విల్ బి మై ఐడెంటిటీ ఎలిమెంట్? ఐడెంటిటీ ఎలిమెంట్ మీరు ఏం తీసుకుంటారు అప్పుడు చెప్పండి. ఓకే, ఇఫ్ యూ టేక్ 0 to 6, ఐడెంటిటీ ఎలిమెంట్ క్రాస్ 7, మల్టిప్లికేషన్ అంటే ఐడెంటిటీ ఎలిమెంట్ 1 ఉంటుంది. నౌ యూ కెన్ ట్రై. 0 హ్యాస్ నో ఇన్వర్స్. 1 ఐడెంటిటీ ఎలిమెంట్ వస్తుంది. 0 తీసుకున్నారనుకోండి. 0 cross 7 alpha equal to 1 రావాలి. Here alpha can be any element of 0 to 6 according to your proposal. 0, 1, 2, 3, 4, 5, 6. సో 0 ఇంటూ ఆల్ఫా ఎంత 0. 0ని 7 తో డివైడ్ చేస్తే రిమైండర్ 1 రాదు కదా, అంటే ఆల్ఫా డస్ నాట్ ఎగ్జిస్ట్. అప్పుడు 0కి ఇన్వర్స్ ఎగ్జిస్ట్ కాదు. But I want to prove that this is an abelian group. So 0 should not be taken when multiplication has been taken as an operation. Exactly, 0 will not come. Yes. So prove that Z7 equal to set of 1, 2, 3, 4, 5, 6 is an abelian group with respect to cross 7. Cross 7 తీసుకోవాలండి. Right. Now let us construct a composition table. So composition table construction is required. It is cross 7, 1, 2, 3, 4, 5, 6. One, two, three, four, five, six. It is cross 7. Right. Now let us try to fill elements of this composition table. Here you can see, here you will get 1, 2, 3, 4, 5, 6. Because 1 is going to be identity element. Next 2 తో multiply చేద్దాం. 2.1 is 2. 2 cross 7. 2 ని 7 తో divide చేయండి. 2 cross 7, 1. 2 into 1 ఎంతండి 2. 2 mod 7. When you divide smaller number with bigger number, the remainder will be smaller number itself. So it becomes 2. 2 into 2, 4. 2, 3, 6. 2, 4, 8. 8 mod 7, 1. 2, 5, 10. 10 mod 7, 3. 2 into 6, 12. 12 mod 7, 5. Similarly, this becomes 3, 6. 3, 3 is 9. 9 mod 7 and 2. 3, 4 is 12, 5. 3, 5 is 15, it is 1. 3, 6 is 18, so it becomes 4. Now this is 4, 1. This is 5. This 4, 4 is 16. 16 mod 7 means 2. 4, 5 is 20. So it is 6. 4, 6 is 24. It becomes 3. Yes. Now it is 5. 5, 2 is 10. 10 mod 7 is 3. 5, 3 is 15. 15 mod 7, 1. So 20 mod 7. 20 mod 7 is 6. 5, 5 is 25. 25 mod 7. 7, 3 is 21. It is 24. 5, 6 is 30. 30 mod 7. It is 2. Now it is 6. It is 6, 2 is 12. 12 mod 7 means 5. 6, 3 is 18. It is 4. 6, 4 is 24. 3. I think it is 2, it is 1. Yes, you are getting in the reverse order. I think it is, my points are clear. Now you can look at this. If you call it as matrix M, here M is becoming M transpose. M is same as M transpose. So it is a symmetric matrix. Please look at this. All elements of composition table are again elements of 1, 2, 3, 4, 5, 6. So closure property is clear. Associative will be clear. What will be my identity? It will be 1, and even you can get the inverse. M is same as M transpose, so it satisfies closure, associative, identity, inverse. and commutative properties. Hence, my conclusion will be Z7 comma cross 7 will be an abelian group. Okay. So, a points into Radham Chondok. After this, immediately I will go to definition of ring. First, let me talk about closure law. Since all elements of composition table or elements of Z7 implies Z7 satisfies closure law with respect to cross 7. Associative law you can write directly. You can write directly A cross 7B cross 7C is same as A cross 7 B cross 7C for all A comma B comma C belongs to Z7. Next to identity element. Here you can say directly 1 is an identity element. So no proof is required. Directly with simple observation you can say 1 is an identity element. Next, let's go to inverse. So let's try to get the inverse. Let's go through composition table previous. So obviously 1 inverse is 1. Second row లో 1 ఎక్కడ వస్తుంది 4 దగ్గర వస్తుంది అంటే 2 కి ఇన్వర్స్ ఎవరు 4. థర్డ్ row లో 1 ఎక్కడ వస్తుంది 5 దగ్గర వస్తుంది సో 3 ఇన్వర్స్ is 5. ఫోర్త్ row లో 1 ఎక్కడ వస్తుంది 2 దగ్గర సో 4 ఇన్వర్స్ is 2. In fifth row 1 will come in third column, that means 5 inverse is 3. In sixth row 1 is coming in sixth column, that is 6 inverse is 6. Are you following, students? Okay, I am going to write that. Inverse law. 1 cross 7 1 equal to 1 implies 1 inverse is 1. If you observe closely in any group, the inverse of identity element will be itself. Next to 2 దగ్గర చూద్దాం 2 cross 7 4 1. So 2 inverse equal to 4. Next to 3 cross 7 5 equal to 1. So 3 inverse equal to 5. 2 కి ఇన్వర్స్ 4 అయితే 4 కి ఇన్వర్స్ 2 వస్తుంది 4 cross 7 2 equal to 1 implies 4 inverse equal to 2. Next to 5 cross 7 3 equal to 1 implies 5 inverse equal to 3. 6 cross 7 6 is 1 implies 6 inverse equal to 6. So inverse exists for every element in the same set. So here I am going to write that inverse exists for every element in Z7. Inverse exists for every element in Z7. So inverse property is clear. Next, commutative law. So directly you can write A cross 7B is same as B cross 7A. For all A comma B belong to Z7. A star B equal to B star A. For all A comma B belong to G. G means Z7, star means cross 7. So here Z7 comma cross 7 is an abelian group. Is an abelian group. Now I'm going to generalize these 2 points. I'm going to write general points. Note. Zm comma plus m is an abelian group. Point number 1. Next, Zm comma cross m is an abelian group. In this case, in case of first set, my elements will be 0 to m minus 1. 0, 1, 2, 3 and so on m minus 1. But in case of what will be the elements of Zm when the operation is cross m. So here Zm is set of all positive integers less than m and relatively prime to m. Here I made 2 conclusions. Here for addition modulo m and for multiplication modulo m, I followed the same notations. Students, try to observe these changes. Even if the operation is plus m, even if the operation is cross m, my notations are same, Zm. Then how to differentiate them? Simple అండి. Addition modulo 6 తీసుకుంటే elements 0 to 5 తీసుకోండి. Addition modulo 100 తీసుకుంటే 0 to 99. అదే మీరు multiplication modulo 100 తీసుకుంటే you take all numbers from 1 to 99 which are relatively prime to 100. What do you mean by relatively prime? Those numbers maintain greatest common divisor 1 with a given number. They are called relatively prime integers. Let's take example. Suppose Z20 cross 20 కావాలి elements. Z20 తీసుకోండి. You start from 1. Just don't take 2. 2 and 20 are not relatively prime. GCD of 2 comma 20 is not 1. Here GCD stands for greatest common divisor. GCD stands for greatest common divisor. So GCD value suppose మీకు ఇలా ఉందనుకోండి. Here GCD of 2 comma 5. GCD greatest common divisor of 2 comma 5 is 1. So therefore 2 comma 5 are relatively prime. So when numbers maintain greatest common divisor 1, they will be called as relatively prime. So 2 తీసుకోవద్దు. 2 and 20 are not relatively prime. Next 3 తీసుకోండి. Don't take 4. All even numbers, they are not relatively prime to 20 because 20 is even number. So don't take multiples of 2. So 4 తీసుకోవద్దు. 5 తీసుకోవద్దు. 5 and 20 are not relatively prime. Don't take 6 also. 7 తీసుకోవచ్చు. 7 maintain GCD 1 with 20. 8 తీసుకోవద్దు. 9 తీసుకోండి. Don't take 10. 11. Don't take 12. You can take 13. Don't take 14. Don't take 15. 15 is a multiple of 5. 20 is a multiple of 5. So 15 is not relatively prime to 20. 16 తీసుకోవద్దు. You can take 17. Don't take 18. You can take 19. సార్ మధ్యలో వేరే నంబర్స్ ఇంక్లూడ్ చేస్తే ఏమవుతుంది? ఇన్వర్స్ ప్రాపర్టీ కానీ క్లోజర్ కానీ ఫెయిల్ అయ్యే ఛాన్సెస్ ఉంటాయి. దే డు నాట్ ఫార్మ్ ఎన్ abelian గ్రూప్. సో ఇన్ దిస్ కేస్ Z20 comma cross 20 is an abelian group. అదే మీరు ఎడిషన్ మోడ్లో 20 తీసినారనుకోండి. Z20 ఎడిషన్ మోడ్లో 20. Now you don't have any restriction. 0 to 19 తీసుకోవచ్చు. So 0, 1, 2, 3 and so on 19 we can take safely. So that's why previously I wrote these points. When the operation is addition modulo m, without any hesitation take the elements from 0 to m minus 1. If the operation is multiplication modulo m, you should take set of all positive integers less than m and relatively prime to m. Hope this point is clear. Students, sorry following. Yes, relatively prime means co-prime. GCD1. Here I will write the definition. Here I am writing the definition. Relatively prime numbers. Two positive integers a comma b are said to be relatively prime if GCD of a comma b equal to 1. I will write examples here. GCD means greatest common divisor. Here you can look at this. GCD of 2 and 3 is 1. GCD of 2 comma 7 is 1. GCD of 7 comma 11 is 1. So here it means that 2 comma 3 are co-prime, relatively prime. 2 comma 7 are relatively prime. 7 comma 11 are relatively prime. Hope this point is clear. Right. Now I will go through definition of ring. Very, very important definition. So let me start with some non-empty set R. Suppose R is any non-empty set. R is any non-empty set. Assume that there are two binary operations. One is addition, another is multiplication on R. So don't take that whenever I take plus, it strictly maintains for addition. Whenever I take dot, don't think that it is strictly meant for multiplication. As we have seen previously, star can be addition, star can be plus 6, star can be matrix multiplication, star can be addition modulo 6, star can be, symmetric difference between sets. That depends on elements of given set. So here plus is one operation, dot is another operation. Both are binary operations on R. In case of group, we always maintain with a single operation. But in case of ring, you always take a non-empty set with two different binary operation on that set. As you know all, when you maintain a non-empty set with some binary operation, that will be called as an algebraic system. So you take, if star is a binary operation on the set G, then ordered pair G comma star will be called as an algebraic system. Okay, right. Now look at this. Let R be any non-empty set and plus comma dot be two binary operations on R. Then an algebraic system R comma plus comma dot is said to be a ring if it satisfies the following. If it satisfies the following. Three properties are there. The first property is R with respect to plus is an abelian group. Second one is R with respect to second operation, that is dot, is a semi group. So second operation to me group was also like semi group sufficient. Next third, in third one two properties. One is A plus B dot C is same as A dot C plus B dot C. Second one is A dot B plus C. This is same as A dot B plus A dot C. For all A comma B comma C belong to R. The last two are, they are called distributive laws. They are called distributive laws. I think definition is clear. Suppose we are dealing with a non-empty set R. R is some non-empty set. Any elements you can take. So I am dealing with the two binary operations on R. Call them as plus and dot. So whenever something is a binary operation on some non-empty set, when you group those two, that will be called as an algebraic system. So in that case, I am combining OR along with addition and multiplication symbol. So that is called an algebraic system. So if R is any non-empty set and plus comma dot are two binary operations on R, then in that case, the algebraic system R comma plus comma dot is said to be a ring if it satisfies three important properties. With respect to first operation, R should be an abelian group. With respect to second operation, it should be semi-group. Now with respect to plus and dot, they should satisfy distributive laws. A plus B dot C equal to A dot C plus B dot C. A dot B plus C, this is dot here. Here dot is written before plus. Dot is written on the left of plus. So this second law is called left distributive law. Here dot is written on the right of plus, that is called right distributive law. So together I can call them as distributive laws. So R plus should be abelian, R comma dot should be semi-group, and it should satisfy distributive laws. Right. Now we discuss commutative ring. So commutative property is required. Ring lo already commutative property untundi kada. So ring lo already R comma plus is an abelian group. అందులో commutative property వస్తుంది కదా. మళ్ళీ commutative ring ఏంటి? So with respect to second operation. So if a ring satisfies commutative property with respect to second binary operation, that will be called as a commutative ring. That will be called as a commutative ring. Hope this point is clear. So R is a non-empty set. I am dealing with the two binary operations plus and dot. We say that this algebraic system is a ring if it satisfies three properties. With respect to first operation, this should be abelian group. Abelian group lone commutative property cover avutundi. With respect to which operation? With respect to first operation. Second operation to manaki semi group aithe chalu. అంటే క్లోజర్ అసోసియేటివ్ వర్కౌట్ అయితే చాలు. సో అక్కడ కాంపిటేటివ్ ప్రాపర్టీ వస్తుందని ఎష్యూరెన్స్ లేదు. దెర్ ఇస్ నో గ్యారంటీ. అండ్ ఎడిషన్ టు దట్ డిస్ట్రిబ్యూటివ్ ప్రాపర్టీస్. సో వెన్ డూ సే దట్ ఎ రింగ్ ఈస్ కాంపిటేటివ్ రింగ్? When do you say that a ring is commutative ring? If it satisfies commutative property with respect to second binary operation. I am going to write that. A ring R comma plus comma dot is said to be commutative ring if A dot B equal to B dot A for all A comma B belong to R. I think definition is clear. So this is the definition of commutative ring. Next, unity element. Next, let's talk about unity element. See here, unity element is nothing but one type of an identity element. Unity element is nothing but one type of identity element. Already మీకు R comma plus abelian group వస్తుంది కదా. ఆర్ కామా ప్లస్ ఎబిలియన్ గ్రూప్ వస్తుంది కదా, అందులో మీకు ఐడెంటిటీ ఎలిమెంట్ గ్యారంటీ వస్తుంది కదా. ఆ ఐడెంటిటీ ఎలిమెంట్ ఏ ఆపరేషన్ తో వస్తుంది? విత్ రెస్పెక్ట్ టు ప్లస్ తో వస్తుంది. సో విత్ రెస్పెక్ట్ టు డాట్ తో ఐడెంటిటీ ఎలిమెంట్ వస్తుందని గ్యారంటీ లేదు. దట్ ఈస్ ఓన్లీ సెమీ గ్రూప్. సో ఇఫ్ యూ హ్యావ్ ఐడెంటిటీ ఎలిమెంట్ విత్ రెస్పెక్ట్ టు సెకండ్ ఆపరేషన్, then we can say that R is a ring having an unity element. So in simple words, I can say that unity element is nothing but identity element with respect to second operation, that is dot. Here I am going to write like this: a ring R comma plus comma dot is said to have unity element if there exists B belongs to R such that say for example x dot B equal to B dot x equal to x for all x belong to R. I think this point is clear. మామూలు మల్టిప్లికేషన్ లో మీరు b ప్లేస్ లో 1 assume చేసుకోండి. when you multiply every element with 1 you will get back same element x. b ప్లేస్ లో 1 assume చేసుకోండి. x dot 1 equal to 1 dot x equal to x for all x. so the multiplicative identity. ఇక్కడ నాకు ఎలిమెంట్స్ ఏంటో తెలియదు కాబట్టి I do not know whether normal elements are going to be the elements of given ring. So here I maintained B. I think the point is clear. Understand? What's your doubt, Srinivas Rao? To becoming a commutative ring, it should be a ring or not? Obviously, student good student అండి. మీరు గుడ్ స్టూడెంట్ అవ్వాలంటే ఫస్ట్ స్టూడెంట్ అవ్వాలి కదా. ఓకే, సో కాంపిటేటివ్ రింగ్ అవ్వాలంటే ఫస్ట్ రింగ్ అవ్వాలి. కాంపిటేటివ్ రింగ్ అవ్వాలంటే ఫస్ట్ రింగ్ అవ్వాలి. దట్ ఈస్ క్లియర్. ఓకే, సో యూనిటీ ఎలిమెంట్ అంటే ఐడెంటిటీ ఎలిమెంట్ విత్ రెస్పెక్ట్ టు సెకండ్ ఆపరేషన్. ఐడెంటిటీ ఎలిమెంట్ విత్ రెస్పెక్ట్ టు సెకండ్ ఆపరేషన్. ఎనీ డౌట్స్ ఆన్ దిస్? పాయింట్స్ ఆర్ క్లియర్, రైట్? Now we discuss the definition of field. Very, very important. ఈ డెఫినేషన్ కంప్లీట్ అయితే చాలండి. టుమారో we can start the session directly with the definition of vector space. Field. Have you heard the name field? Field అనే వర్డ్ ఎప్పుడైనా విన్నారా? Actually, field is name of a mathematician, very famous mathematician. Field is name of a famous mathematician. I will tell you one interesting point about field. Every year, committee will decide Nobel laureates on December 10th. That is on the death anniversary of Nobel. So they are going to they are going to release the names of Nobel laureates in the fields of English, in the field of English, in the field of literature, in the field of economics, in the field of physics, chemistry, etc. Have you heard that any mathematician won Nobel Prize till now? Have you heard? No mathematician won the Nobel Prize till now. It doesn't mean that India has no extraordinary mathematicians. It's not like that. Our world has no extraordinary mathematicians. We had extraordinary mathematician, Professor Srinivas Ramanujan. Okay, if Srinivas Ramanujan is alive by today, so he would have got 100 Nobel medals. There is no doubt in that case. The point is, Nobel Prize will not be given to mathematics people. So ultimately, mathematics people will get angry. So they have got angry. So the committee have decided one medal on the name of Field, a famous mathematician, where the prize money is 10 times more than Nobel Prize. Field's medal. So Field is a very famous mathematician who died at the young age. On his name, a lot of research have been introduced. And for real vector spaces, the motivation is field. Okay, so let me define field definition. And once I complete the definition of field, let me talk with the two different examples of field. And tomorrow directly we can start the session with vector space. So field starting letter F ఉంది కదండి. So we use the notation for F. Okay. Now let us see what is the definition of a field. A commutative ring with unity in which every non-zero element has a multiplicative inverse is called a field. This is the definition of field. So field అవ్వాలంటే first of all ring అవ్వాలి. It should be commutative. Unity element should be there. And every non-zero element should have multiplicative inverse. So indirectly what I'm going to say is, suppose if this is my set F. So ring అంటే మీకు two operations కావాలి, plus dot. Ring అవ్వాలంటే first of all F comma plus ఎలాగో abelian group అవ్వాలి. What about F comma dot? No guarantee. So F comma dot కూడా అంటే రింగ్ లో మీకు F comma dot ఎలాగో సెమీ గ్రూప్ అవుతుంది. ఐడెంటిటీ ఎలిమెంట్ ఉంటుందా, గ్యారంటీ ఉంటుందా? ఎస్. హియర్ ఐ మెన్షన్ వెరీ క్లియర్లీ దట్ యూనిటీ ఎలిమెంట్. సో మోనాయిడ్ వస్తుంది. ప్రతి ఎలిమెంట్ కి ఇన్వర్స్ వస్తుందా? ప్రతి ఎలిమెంట్ కి ఇన్వర్స్ రావాల్సిన అవసరం లేదు. విత్ రెస్పెక్ట్ టు ఎడిషన్, because my first operation is addition. With respect to first operation, what should be my identity element? 0. So 0 ki multiplicative inverse guarantee ledu. Andukani ikkada here I mentioned every non-zero element has a multiplicative inverse. Ante commutative property ravali, closure property elaga vastundi. I am talking with respect to second operation. What is the definition of field? A commutative ring with unity in which every non-zero element has multiplicative inverse is called a field. So commutative ring అవ్వాలంటే first of all ring అవ్వాలి కదండి. So ring లో మీకు two operations ఉంటాయి. One is plus, another is dot. So if you want to say that something is a ring with respect to first operation, it has to be abelian group. Now here dot is there. Here I don't have any assurance about the inverses of non-zero elements. If that is also going to be happen in case of dot, అంటే జీరోకి ఎలాగో మల్టిప్లికేటివ్ ఇన్వర్స్ ఉండదు. జీరో గురించి మీరు ఎందుకు మాట్లాడుతున్నారు? విత్ రెస్పెక్ట్ టు ఎడిషన్, జీరో విల్ బి మై ఐడెంటిటీ ఎలిమెంట్. సో జీరో డెఫినెట్ గా ఉంటుంది, బికాస్ ఐఎమ్ డీలింగ్ విత్ టూ డిఫరెంట్ ఆపరేషన్స్. వన్ ఈస్ ప్లస్, అనదర్ ఈస్ డాట్. సో విత్ రెస్పెక్ట్ టు డాట్ తో ఎలాగో జీరో అనే ఐడెంటిటీ ఎలిమెంట్ కి ఇన్వర్స్ ఉండదు, యూనిటీ ఎలిమెంట్ ఉండాలి. అలా ప్రతి నాన్ జీరో ఎలిమెంట్ కి మల్టిప్లికేటివ్ ఇన్వర్స్ ఉండాలి. అంటే indirectly F comma plus is an abelian group, F comma dot also an abelian group, except existence of inverse for zero element indirectly. So F plus abelian group అవ్వాలి, F comma dot abelian group అవ్వాలి. అంటే అక్కడ F లో జీరో ఉంటుంది కాబట్టి జీరో ఎక్సెప్షన్ కేసు ఉంటుందండి. That's the thing. Understand my dear point? Yeah, Chakri, what's your doubt? Srinivas Ramanujan, the man who knew infinity. Exactly, he was the founder of infinity. No doubt. Who said that's not true? That was absolutely true. Srinivas Ramanujan. He was a great personality, great mathematician who invented infinity, who introduced infinity to the whole world. Okay? There is no doubt in that case. Any doubt in the definition of field? Students, any queries? Definition of field. Okay, let me go through examples. So we have two examples. First one is r comma plus comma dot is a field. Second one is c comma plus comma dot. Here R stands for set of real numbers. C stands for set of complex numbers. So both are Both form fields with respect to normal addition and with respect to normal multiplication. Any doubts on this, my dear students? R comma plus comma dot. Let us verify. I think definition of field is very clear. A commutative ring with unity in which every non-zero element has a multiplicative inverse is called a field. The famous examples are set of real numbers is a field with respect to usual addition and with respect to usual multiplication. The second one is set of complex numbers with respect to usual addition and with respect to usual multiplication is a field. Let us verify. So let us talk about just R comma plus comma dot. Here R is set of real numbers. First ring verify చేద్దామండి. We know that set of real numbers with respect to plus is an abelian group. That is very clear. R comma dot real numbers with respect to normal multiplication is a semi group. Distributive laws ఎలాగో వర్కౌట్ అవుతాయి. So this is a ring. Up to this I can say that R plus dot is a ring. Next, a commutative ring. We know that A dot B is same as B dot A. That is true in every case of two real numbers. Commutative ring. What is unity element? What is unity element? Multiplicative identity. 1. 1 is a real number, right? 1 is a real number where A dot 1 equal to 1 dot A equal to A for all A belongs to R. So here multiplicative identity is nothing but unity element. Inverse వస్తుందండి. Existence of inverse for every non-zero element. If A is non-zero, implies 1 by A is a valued real number and A dot 1 by A equal to 1 by A dot A equal to 1 implies every non-zero element of R has a multiplicative inverse. Has a multiplicative inverse because here dot is operation. What is A inverse? 1 by A. Prati non-zero element ki multiplicative inverse vastundi. Understand? So therefore in this case R comma plus comma dot is a field. In the similar way, you can also prove that set of complex numbers with respect to addition and multiplication will be a field. So hope you understand definition of ring, commutative ring, examples along with fields. So throughout the vector space, we always use two famous examples. So one is set of real numbers, another one is set of complex numbers. So tomorrow we directly start the session with the definition of vector space, examples of vector space, subspace, linear span, dimension and various examples. Tomorrow also you will be having very full fun. Did you understand this class? All of you? Any queries, students? Follow your endeavor. Srinivas Rao, Mahesh, Chakri. Follow your endeavor. No issues at all. Points are clear. Okay. So tomorrow directly we can start the session with the definition of vector space followed by examples, subspace, linear span, linearly independent vectors, basis, dimension. Right. This is official Creatrix channel where you can find more than 10,000 members. This is our Telegram channel where you can get the links of our live classes and notes in PDF format. These are India's #1 study channels running by Unacademy. Thanks a lot, guys. Thank you for bearing me since last 1.5 hours. See you tomorrow. Good night.